Welcome back. In today's explainer, we're taking a look at a fascinating clash of titans in the world of AI-generated cinematic video. We aren't just talking about basic slideshows or, generic stock footage mashups anymore. We're talking about code-driven, highly polished, dynamic motion graphics generated entirely by artificial intelligence. Just a few months ago, if you wanted an AI to build a polished explainer directly from code, Remotion was basically the undisputed champion. But a new challenger just entered the ring: HyperFrames. It's a framework built entirely around native HTML, CSS, and JavaScript, specifically tailored for AI coding agents. Okay, let's dive into this and see how these two heavyweights stack up against each other.
So here's the ultimate question for developers and creators right now. Which framework actually builds the better video? And I guess more importantly, which one should you be investing your time into learning and integrating into your own workflow? If we take identical instructions, like the exact same creative brief, and hand it to these two totally different frameworks, who comes out on top? Does the React-based, highly structured approach of Remotion get the win? Or does the HTML-native, AI-centric architecture of HyperFrames take the crown? Well, we're going to answer that by looking at an incredibly clever, controlled experiment designed to stress test exactly how these engines think.
To figure this out, we really can't just look at two random finished videos and guess why they look different. That's what most people online do, and frankly, it leaves way too much room for AI hallucinations, variable prompting, or just simple human error. Instead, we're framing this explainer around a high-stakes, highly controlled scientific experiment. We have to completely isolate the framework itself. By controlling literally every single variable from the ground up, we ensure that any differences we see at the finish line are purely a result of the framework's internal logic, not the instructions it was given. We're essentially putting them in a vacuum to see what they're really made of.
Alright, here are the strict rules of the game to prove this is a fair apples-to-apples comparison. First, both frameworks are fed the exact same storyboard and creative direction, down to the letter. Second, they're both driven by the exact same AI model, Claude Opus 4.8. We chose that specifically for its insanely deep reasoning capabilities in complex, multi-layered coding tasks. And third, the build happens using the exact same prompts. So we're essentially giving two completely different machines the exact same raw materials and blueprints, hitting start at the exact same time and just stepping back to watch what happens.
But before we hit run on the experiment, we need to understand how to actually talk to these frameworks, specifically HyperFrames, since it's kind of the newer kid on the block. When you look at the showcase projects published by the HyperFrames team, something really interesting jumps out. Whether it's a sleek product launch, a financial breakdown, or a vibrant demo website, the visual stories change completely, but the underlying production techniques, they are remarkably consistent. The core engine running underneath all these vastly different projects is built on the exact same foundational design principles.
When we peek directly into the source code of those projects, an undeniable pattern emerges. We see the same highly specific visual effects appearing over and over again. I'm talking about rich glassmorphism, intricate custom cursor interactions, precise typewriter text, texture masked typography, chromatic RGB splits, complex shader effects, and cinematic portal reveals. If you're a developer, you already know that coding just one of these effects from scratch can easily take hours of trial and error. It's a rapid-fire list of high-end production value, and seeing an AI consistently deploy them is frankly a little mind-bending.
So the crucial point is, we absolutely don't want to force our AI to reinvent the wheel and figure out how to code a chromatic RGB split from scratch every single time it boots up. That is a massive waste of computing power. Instead, all of those recurring visual effects are extracted and packaged into a reusable production skill. Think of it like giving a master chef a pantry full of perfectly pre-made signature sauces, instead of forcing them to grow their own tomatoes from seeds for every single meal. By feeding this custom skill to Claude, we're effectively teaching the AI the techniques behind all those polished showcase projects instantly. It gives Claude a massive foundational head start.
Okay, next up is the foundation for the entire experiment, the creative blueprint. Now, this isn't just a basic one-paragraph summary of what the project is about. No way. It is a deep, intentional, comprehensive document. The storyboard defines the typography, color palettes, strict motion rules, transition styles, and the core philosophy of every single scene. It dictates not just what is being taught, but exactly how the motion should feel. This ensures Claude has a razor-sharp creative direction before a single line of code is written. Honestly, this is a huge takeaway for your own projects. The better your initial blueprint, the less the AI has to guess. With the blueprint set, we move to the build execution, which relies on a precise three-prompt process. Now, you might be wondering, why 3 prompts instead of just asking the AI to build the whole thing at once? Well, it comes down to how AI context windows work. If you ask an AI to do the whole shebang at once, it loses context, gets overwhelmed, and starts hallucinating bad code. Breaking it down forces strict logic. Prompt 1 builds the basic foundation and project structure. Prompt 2 brings the actual scenes and effects to life, and Prompt 3 applies the final polish and handles the complex export. Both frameworks are going to go through this exact same sequential gauntlet.
All right, let's look at phase 1. Kicking things off with HyperFrames, the creative blueprint, the custom HyperFrames production skill we just talked about, and Claude Opus 4.8 are all locked in. After Prompt 1, well, we don't have a finished output yet, just a really healthy, robust project skeleton. But as Prompt 2 runs, the HTML, CSS, and JavaScript start compiling beautifully. The scenes actually populate with real substance. And then Prompt 3 executes the final polish pass, rendering out a fully deterministic video output. That basically means every single time you hit play, the code guarantees it's going to look exactly the same, down to the pixel, with zero random AI generation glitches.
Now, what's really interesting about this slide is that the final result HyperFrames delivers from this process is nothing short of incredible. Because the AI was armed with that reusable production skill, the motion feels unbelievably smooth and deliberate. The transitions from scene to scene are highly cohesive, the typography is sharp and modern, and it adheres flawlessly to the creative blueprint we provided. For an almost entirely AI-assisted production, it's a shockingly polished output. It genuinely feels like a seasoned motion designer sat down and carefully crafted the keyframes, rather than, a large language model writing web code in the background.
But hey, the experiment isn't over yet. We now reset the board completely for Remotion. We keep the exact same storyboard, the exact same creative direction, the exact same Claude Opus 4.8 model, and those exact same 3 sequential build prompts. The one single difference, we swap out our custom HyperFrame skill for the official Remotion skill, which teaches the AI to build using React components rather than pure raw HTML and CSS. Every other variable remains in complete lockdown, so we can see exactly what happens when the underlying technology shifts.
So we run the 3-prompt process again: foundation, scenes, polish. And the Remotion output? It performs brilliantly as well. The motion is highly polished, the visual quality is striking, and it faithfully tells the exact same story we mapped out in the original blueprint. But here is where it gets absolutely fascinating. Even though it's the identical story using the identical AI, as a viewer, you can actually feel the underlying differences in how the framework attacked the problem frame by frame. It just has a distinctly different texture to its movement.
And this brilliantly illustrates the core divergence between these two tools. We gave them the exact same map, but they took completely different vehicles to the destination. On one side, HyperFrames operates like a fluid river. It is inherently web-native and AI-first, adapting seamlessly and flowing organically. On the other side, Remotion builds like a rigid, perfectly laid brick road. It relies on a highly structured, strict, developer-first architecture. They both get you where you need to go, for sure, but the engineering philosophy driving the engine couldn't be more opposed.
Breaking down these differing features side by side really reveals exactly what you need to take away from this explainer. HyperFrames uses native HTML, CSS, and JavaScript. And because the web was inherently built for this kind of flexible rendering, it allows the AI to focus heavily on creativity, making things look beautiful, bouncy, and fluid without overthinking the math. Remotion, however, expresses every single animation through React components, forcing the engine to calculate everything strictly frame by frame. Because React is rigid by design, when the AI uses Remotion, it has to focus its energy on rigid structure, complex math, and absolute code correctness. It basically prioritizes flawless engineering over artistic interpretation.
Ultimately, the AI is a massive assist in both frameworks, but they are clearly optimized for entirely different jobs. If your project demands strict architectural correctness, programmatic scalability, and React-level precision, Remotion is absolutely your undisputed powerhouse. But if you want the AI to lean fully into visual creativity, incredibly smooth transitions, and high-end aesthetic polish using web-native code, well, HyperFrames is an absolute revelation. Both are incredible tools, but they require you to pick a philosophy. So as you look at your own workflow, I leave you with this. When you sit down to build your next big idea, will you anchor it in the structured precision of a developer or unleash the fluid creativity of an AI? The choice is yours.